Hey, Woodleen, it's good to see you. Thanks for joining us. If you're joining us, feel free to say hi in the chat. Awesome to see you, Ladanian. We will get started at 1:10. You might have just seen me post that there anyways. So we're going to wait a few more minutes to see if people show up with that link, and then we'll get started on the 5th lesson. Charlize, great to see you as well. Go ahead. And who is that Zamil? Is my guess. How you doing, guys? Marcus, awesome. Good to see you, Marcus. Thanks for joining us. And Fatimata, good to see you too. Thanks for joining us. And as usual, Donald here with us. Good to see you, buddy. Alright, I'm going to spend this weekend trying to figure out how to use Zoom better so we can switch these over to Zoom too, so we can at least see your faces and have you answer some questions, explain some things. So today, hopefully, is going to be the last one we use on YouTube. We'll start using Zoom, and I'll figure out a way to show my whiteboard and other stuff on Zoom. Michaela, very good to see you. Thank you for your consistent work and continuing to learn, being here with us every day. Alright, and I'll mention it one more time. We're going to start in about 2 minutes. Once we get to 1:10, we'll give people a minute or two to join, but then we're going to get going. Alright, hopefully you all have already started and worked through some of these problems. If you haven't, definitely have that document up or be loading that document. And Jefferson, good to see you, buddy. Thanks for joining us. Alright, so we are at 1:10. I'm going to go ahead and get started on the lesson at this point. So for our lesson today, you see the title for the assignment is Problem Solving with Area and Volume. Basically, we've been working with these formulas for different shapes to find their area or volume. Today, I think the big challenge is going to be a lot of times towards the middle and end of the document, they'll tell you the volume and have you figure out one of the other dimensions. So it is definitely getting a little more challenging here. The first problem we have, again on page 2 you have your reference sheet, talks about for circles how to find area and circumference, talks about for all these different shapes how to find volume. And Drippy Clips, thank you for joining us. I'm trying to remember who had that name. Did Julie maybe? I can't remember who it was. Or Marco, one of the two. But thank you for joining us. So the first problem we're going to look at is very similar to a lot of the stuff you're going to see either on IXL or Khan Academy. They give you different shapes. Oh, it's Benji. Okay. Thank you for letting me know, Michaela. So the first shape we have is actually a circle. They ask us to find the circumference and they ask us to find the area for that circle. So what I'm going to do on my screen, I'm going to scroll up and show you in the reference sheet for a circle here. We have two different formulas. One helps us find the area. That's area equals pi times radius squared, which measures how much space the circle takes up. I thought it might have been Marco. Good to see you, Marco. And then for circumference of a circle, that's going to be pi multiplied by diameter. So for the very first problem we have today, and this is related to assignment 2 and 3 on Khan Academy, they ask you to find the circumference for the circle, they ask you to find the area. Feel free to identify for us in the chat how you found circumference, how you found area, or what those answers are. I'm going to show that on my whiteboard. Circumference, and I'll make the whiteboard a little bit larger right now. Circumference measures how far the distance is around the perimeter or the outside of a circle. The formula is pi multiplied by diameter. If I do pi multiplied with whatever the diameter for a circle is, then that's going to tell me the circumference. I'm with Michaela. I would be taking a circumference, or to find it, pi could be switched into 3.14. And the diameter is 14, like Michaela states. So you'd be doing 3.14 times 14. And when you do 3.14 times 14, using my calculator to figure out, that gives me 43.96. So I'm with Fatumata on 43.96 being the right answer for our circumference. Since circumference just measures a singular dimension, the distance all the way around, we're going to leave that 43.96 feet. And it's not going to be square feet. Circumference always just measures a singular dimension, the distance around a circle. The other thing they ask us to do for this circle is to find the area. If I work with the area formula for a circle, you'll see the key, I need to understand what the radius is. Like most of the volume formulas that work with circular shapes, if I'm finding the area of a circle, A, it's going to be equal to pi times radius squared. So the question is, what is our radius for this circle? If we know that the diameter is 14 feet, and we know that radius always measures a distance halfway across a circle, then we know the radius for this circle here is going to be a radius of 7. Half of 14, or 14 divided by 2, gives us a radius of 7. So that's the value we need to plug in for r, for the radius, to find the area of our circle. So we would be doing pi multiplied by 7 squared. When we evaluate, when we do the math to find the area using that equation now, first I'm going to do 7 squared, which gives me 49, and I'm also going to switch pi over to 3.14. So the area is going to be equal to 3.14, or pi, multiplied with 49. When I do 49 multiplied with pi, you could leave your answer as 49 pi. That's probably what Donald and some others are doing. But if I choose to do 49 multiplied with 3.14, the answer that I get is 153.86. Yep, I'm with Michaela, same answer. I'm at 153.86. Thanks for sharing too, Marcus. Good to see a bunch of you are with us. So 153.86 in this case, measured in feet, and any area, since it's length times width, or in this case radius times radius, is going to be in square feet. Our final answer for that circle's area is 153.86 square feet. If you haven't caught up with us on Khan Academy yet, that's totally okay. What we just did there for circumference and area is really the key for the second and the third assignment on Khan Academy for your work. The next shape, feel free to identify for us. I'll go ahead and move the whiteboard into a different spot. What is the name of the next shape we're dealing with? What is the formula that's going to help us find the area of that shape? And there is a bit of a lag. It seems like 10 seconds today between our chat and when I'm talking. So feel free to share answers a little ahead of time. I'm going to keep moving along. I do see Michaela, Donald, they're all identifying this as a cylinder that's kicked over, but still a cylinder nonetheless, so we're going to use the volume formula for a cylinder, which is pi times radius squared times height. If people want to identify for us in the chat what is the height and what is the radius for this cylinder, once you find your formula, the big key is to get the dimensions correct. I am with Michaela on the formula being pi times radius squared times height. So our big question then to find the volume, what is the radius and what is the height for this cylinder? Hopefully we're seeing that the cylinder's been kicked over, it's been moved sideways. So if they kick that cylinder over sideways on us, we see that the 20 that kind of goes across side to side, that's going to be our height for the cylinder. And a little tricky to see here then, if it's kicked sideways, 10 measures the distance all the way across the cylinder's circular base. So as Donald's telling us in the chat, and he's correct, the radius is going to be 5 into the formula. V is going to be equal, or volume for this cylinder will be equal to pi times 5 squared times 20. I'd first do exponents and then multiplication if I'm following order of operations, so it becomes pi times 25 when I do 5 squared times 20. If 25 times 10 is 250, double that, 25 times 20 is going to be 500. So I get 500 times pi for the volume of this cylinder. On Khan Academy, they'll usually take that as a fine answer. It's okay to leave pi as part of your answer. On IXL, they're going to ask you to multiply out by changing the pi into 3.14. So if I do 500 times 3.14, the volume is also, or an estimate for the volume, is 1,570. In this case, we're measured in centimeters. So that's going to be cubic centimeters for the dimension. You could say the volume is 1,570 cubic centimeters. You also could have said that the answer is 500 pi cubic centimeters. That would be fine as well. Awesome. Thank you, Marcus. Thank you, Fatumata. I'm going to keep moving just in the interest of time into the next problems. If you're at home, definitely feel free, or joining us after at home, feel free to pause this video. If you're with us live, feel free to speak up in the chat if anything's going too quickly or didn't make sense. We're going to move to the third one. This time that third problem gives us, just move this stuff a bit. The question is, what is the shape we're working with on the bottom left, that third problem? What is the volume formula that helps us find the volume for that shape? And then what are the dimensions, or the values for the variables we need to plug in? The next shape is a sphere. Anything that looks like a ball, a soccer ball, a volleyball, a basketball, those are all always spheres. The volume formula for our sphere is V equals 4/3. Fraction's a little annoying, but we'll handle that as we go along. 4/3 times pi times radius cubed. Because there's no height, a sphere uses the radius for all three of its dimensions. R is raised to the third power. The only variable we need to know is the radius to find a sphere's volume. Here they were kind enough to give us the radius. The radius is 22 inches. If it measures halfway across that circle, the volume is indeed, or it's going to be based on a radius of 22. So if our radius is 22, I plug that 22 into the formula. A calculator is strongly encouraged, especially when we're getting into the sphere problems. 4/3 times pi times 22 is the radius raised to the third power. PEMDAS, or order of operations, again tells me it makes most sense to be handling the exponent first. So I'm going to do 22 raised to the third power. And when I do that on my calculator, it's a big number, just handle this step by step, 10,648. That's what I got from 22 cubed. So if I have 10,468, that's still going to be multiplied with pi, and that's still going to be multiplied with 4/3. I rearrange the order in my equation because if it's all multiplication, I can multiply those terms in any order I want. And I'm going to handle pi, the irrational number, last. And I'm going to instead do 10,648 multiplied with the fraction 4/3. Whenever I multiply with a fraction, I'm really multiplying by the top number. So I'm going to take 10,648. I'm going to multiply that by 4. And then whatever I get, that's why I'm using parentheses, I'm going to then divide by 3. That's the effect of multiplying by 4 over 3. I'm going to switch pi into 3.14. And so all in one fell swoop, I'm also going to take that, which was 14,197.3 repeating, and that has to multiply by pi, which I'm going to put 3.14 in for at this point. So when I multiply that by pi, or by 3.14, I get a volume of 44,579. I did not tell us today correctly where to estimate to. I'm going to round to the nearest hundredth. To the nearest hundredth, that's going to be 0.63. So making that whiteboard a little bit larger, and if you're following us recording at home, feel free to pause it here. We did 22 cubed to get to 10,648. 10,648 times by 4 divided by 3 got us as 14,197, which we then multiplied with pi, or 3.14, to get to a final volume. So that gives us a volume, which I'll go ahead and plug in here. Did people have a similar answer? Did anyone get there? Did people have a different answer than I got at? As we wait to see responses there, I'm going to start transitioning towards the last problem. People with us on the volume there? Hopefully. It is delayed a little bit. Donald says he agrees. Looks like a couple others do as well. So we're going to move on to the last one for number 1. The last real practice one on finding volume. The last shape here, and I'm going to move through this one quickly so we can get into a couple of the more challenging problems. You've seen a lot of ones like this so far if you've been joining us the first few days. We get volume for a cone equals 1/3 times the cylinder formula, pi times radius squared times height. So if we're working with a cone, you'll notice the formula is very similar to the cylinder formula for volume, except 1/3 is a coefficient that's put in there since the cone caves in. Here are dimensions. The key to see for any volume for cones or cylinders, you need to know the radius and you need to know the height. The radius for our cone, the circular base's radius, is 5.7 squared times a height of 12. At this point, you could certainly go ahead and do 5.7 squared, or figure out what 5.7 times 5.7 is. First thing I'm going to actually do, I noticed this 1/3, which is kind of an annoying fraction to divide by 3. I do know that 12 divides by 3 or multiplies by 1/3 to make a whole number. I know that 1/3 of 12, or 12 divided by 3, would make 4. So to simplify this formula a little bit, I switched 12 times 1/3 into 4, and I still have the pi, and I still have the radius squared, or 5.7 squared. I'm going to then do 5.7 squared, which gives us 32.49. So I could do 32.49 multiplied with that 4, and that would give me 129.96, and that still needs to be multiplied by pi. So at that point, you could put your answer in as 129.96 pi. I'm going to multiply out the 3.14 like they would ask us on IXL. And that would give me 408.07 if I were rounding off. Kind of ran out of room on the whiteboard there, I'm sorry, but if I do 129.96 multiplied with 3.14 for pi, I get 408.0744, and I'm going to round that off at 408.07. That will be measured in cubic centimeters. That kind of brings us to the end of problem 1, which was a lengthy problem. It kind of shows you everything you need for most of the IXL and Khan Academy assignments. There were also kind of trickier versions, so if it did seem like a bunch, hopefully you're seeing the main thing: use the formulas, plug the numbers in, use your calculator to work through the formula, and that's how I can find volume for any of these shapes. The second half of this lesson, as we transition now, the second half of this lesson is going to be focused on problems where they provide you with the area or the volume, and you need to use the formula almost to work backwards to go figure out what was the radius or the diameter or the height that would have produced the kind of area or volume we're dealing with. The first problem, number 2, and some of this is popped up on Khan Academy, part of why we put it in here. On number 2, they're going to talk about a circle. We did a circle problem a little bit earlier here when we found circumference and area for this blue circle. But now for problem 2, they're going to tell us the circumference of the circle, and they're going to ask us to determine the radius. So I'm going to erase the whiteboard, and I'm curious in the chat, for this problem, what could you be doing? What would be helpful to figure out the radius of a circle if you already know the circle's circumference? Again, if I already know the circle's circumference, what could I do to try to figure out the radius for that circle? Hopefully, some of us are seeing if it's talking about the circumference of the circle, we need to use the circumference formula for a circle. And that circumference formula, Michaela helped us a little bit earlier. She said if we do pi multiplied by diameter, then we're going to figure out circumference. And as Donald is telling us in the chat, and he's correct, if I use that formula, circumference equals pi times diameter, and I know my circumference instead, in this case I know the circumference is 62.8 inches, and that is equal to pi multiplied by diameter. Donald is correct that if we divide by pi, or in this case they've asked us to use 3.14 for pi, so that's what I'm going to switch all the pi's to. If we divide by the pi that's multiplied with diameter, that isolates or gets the diameter solved all by itself. To find the diameter, the circumference formula tells me I could do circumference divided by pi, and that will give me diameter. So in this case I need to do 62.8 divided by 3.14, and that gives me a diameter of 20 inches. If I have a diameter of 20 inches, part of the challenge for this problem is what is the radius? And if the radius is 20 inches, if the diameter is 20 inches, that tells me ultimately that the radius is going to be half of that, or the radius has to be 10 inches. So the correct answer for number 2 would be A. Make that whiteboard a little bit larger before we move to problem 3, so if you're following the recording or even afterwards, feel free to pause this, take a look to find diameter or to find radius. If they give us circumference, we first have to work backwards to diameter, and then we could change that diameter into radius by cutting it in half. Alright, we're going to keep charging on to the third problem here. Again, if you've got questions, if something's unclear and you're live with us, please definitely say something in the chat. Otherwise, we're going to keep moving through, and you'll have the recording for later. You can email me and ask me questions. Alright, problem 3. Again, and we're going to do just together 3 and 4. Number 5 will leave you on your own if you really want the challenge of number 5. we're going to do 3 and 4 together, but 3, 4, and 5 are all similar. And that these are the tougher versions of the cylinder cone sphere problems. They tell you the volume up front, and then instead they make you work backwards to one of the dimensions. So here for this one, if they give me a cylinder, they identify that as the shape, and I can see the picture shows me a cylinder. I'm going to use the cylinder's volume formula of V equals pi times radius squared times height. And here they told me the volume, so I'm going to plug volume in for V. V gets replaced or substituted out with 1695.6. They also told me the radius is 6 and to use 3.14 for pi. So I'm going to switch pi to 3.14. I'm going to plug in 6 for the radius. And this problem has asked me to find the height. It says determine the cylinder's height. And I see in this formula, once I replace the volume with what that's equal to, once I replace the radius with 6, the only variable left in this equation is h, the height. So I'm going to need to solve this equation by first simplifying the right side of the equation and then peeling the onion to isolate h, or solving for h. If I do 6 squared, I get 36. And if I do 36 times 3.14, 36 times 3.14 leaves us with 113.04. That's still multiplied with h, so all I did there, I did 6 squared, and then I multiplied the 36, which came from 6 squared, with the pi, which is 3.14, and that gave me 113.04. So now the equation simplifies to say the volume, or 1695.6, is equal to 113.04 multiplied with h. So if this is h's coefficient, 113.04, and I want h all by itself on the right side of that equation, to eliminate the multiplication, I use division. Dividing by the same thing that h is multiplied with, that's inverse operations which cancel each other out. But I need to do the same division of 113.04 on the other side of the equation. Otherwise the equation would break. This keeps the equation balanced when I do 1695.6 and I divide that by 113.04. You see, taking your time, precision is important here. I get exactly 15. And if I went back and if I put 15 back into this formula, if I did 6 squared, 36, times 15, multiplied by 3.14, that would spit out the volume that we see here. So that's a way to double check and make sure my answer is correct. So our height, ultimately, is 15 centimeters. And again, when you're on IXL or cut any of this, get help on Zoom, and then after that we'll kind of sign out. So I'm going to full screen that whiteboard for a second. How we got to the height of 15 centimeters. We plugged that 1695 in for volume. We plugged 6 in for radius. We simplified the equation and solved for h eventually, where we got h equal to 15. Moving on to the final problem that we're going to discuss as a group, which is number 4. As I move to the 4th problem, the shape they provide this time is they tell us right away, and you should be recognizing this is now a cone. And our volume formula for a cone, they tell us the cone's height, they tell us the cone's volume, and the problem ultimately asks us to figure out what is the cone's radius. So if I know the volume for a cone and I know its height, I'm going to use that volume formula for a cone. V equals 1/3 times pi times radius squared times height. I'm going to plug in the volume, which is 2043.72. I'm going to plug in 3.14 for pi, because that's what they told me to use for pi. I don't know the radius yet. That's what we're trying to figure out, so that stays as r squared. And I know the height is 24. So again, from the word problem itself, oh, and I was backwards, this is why we double check. The volume is 2034.72. The height is going to be replaced by 24 centimeters, and we see that on the whiteboard. And we also replace pi with 3.14. So I'm going to go ahead and now simplify the right side of this equation where there's a bunch of numbers. 24 times 1/3, or 1/3 of 24, is going to give me 8. 24 divided by 3 is 8, and that's really what happens when I multiply by 1/3. So that becomes 8 times 3.14 multiplied with r squared, which is still equal to our volume over there. When I do 8 times 3.14, when I continue to simplify the right side of that equation first, I get 25.12 multiplied with r squared, which is going to be equal to 2034.72, the volume we plugged in earlier. I want to get r all by itself, so the first thing I'm going to do to get r squared all by itself is divide by that 25.12. So both sides are going to get divided by 25.12 with the goal of canceling out that coefficient, so this just becomes r squared. If I do 2034.72, that's the volume, and I divide it by this 25.12 we have as a coefficient, I get exactly 81 on the left side of the equation. And if r squared is equal to 81, I could take the square root from both sides if I can't see this answer yet, because square roots are the opposite of squaring a number. And if the square root of 81 is 9, that tells me if r squared equals 81, then the radius must have been 9, because 9 times 9, or 9 squared, is the number that would give us the 81 we need. So that was a bunch of work to get to a radius of 9 centimeters. Again, I think these problems 3, 4, they're very challenging, and our bigger goal is more to find the volume, which came in the first problem sets today. But it looks like a bunch of you are ready to do these more challenging ones we saw, where they give you the volume and have you work out the radius or height, so we figured we'd show some of those today. So again, that's how we end up ultimately with an answer of 9 centimeters for this cone. If you work on problem 5 on your own, it's similar to problem 3 and 4, just a little more challenging as it's using the sphere formula. Is there anyone here with us who wants to go on Zoom to get help with Khan Academy with IXL, or to ask questions about what we just went through? So I've got 8 or 9 of you with us here, and thanks for making it towards the end. Are there any of you who want to get some help on Zoom right now? Or do you think you're all set? Feel free to identify in the chat what you'd prefer. If you'd like to go on Zoom, keep working on some math together, ask questions. But if we don't have anybody who's got that question, we'll wait until Monday for our next Zoom meetup. Alright, so I'll wait a few more seconds and then I'm going to stop the stream, because I haven't seen anyone yet who says, yes, I definitely want to go on Zoom right now to keep talking about math, which I would be happy to do. But if there's no volunteers, I'm going to stop streaming at this point. Thank you for making it this far. I hope you all have a great weekend, and as always, if you've got questions, feel free to reach out to me on Gmail or Google Chat or any other way you can get a hold of me. Thank you, take care, and again, enjoy your weekend.